Hello, welcome to helpyourmath.com. In this video, we're going to discuss about scientific notation, and this is the introduction. Since ancient times, people have been counting stars in the sky and wondering how big the world is. As telescopes became more powerful, more and more stars were discovered. Eventually, people began to wonder if the number of stars in the universe was infinite. At this point, astronomical technology does not allow us to count the total number of stars. However, we do know that the universe is made up of galaxies, and that galaxies are estimated to contain about 100 billion stars on average. It is also estimated that there are about 100 billion galaxies in the universe. In example 1, we ask what mathematical operation you would use to estimate the total number of stars in the universe. One way to understand large numbers is as products or powers of 10. For example, 1,000 is 10 times 10 times 10, which is 10 to the third. So that means each of these zeros after 1 would represent a power of 10. Also, 10,000 would be 10 times 10 times 10 times 10, and that would be 10 to the fourth, because there are 4 powers of 10. In example number 2, we're asked to write 100 billion in standard notation and use the above examples to write it as a power of 10. So here we have 100 billion. So we have to know what this word or how many zeros billion would represent. So 100 billion means it would be 100 with 9 zeros after it. So that means we would have 1, 10, 2, 10, 3, 10, 4, 10, 5, 10, 6, 10, 7, 8, 9, 10, 11. So we would have to multiply 11 tens. 10 times 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 10, which would be 10 to the 11th. Based on the answers for 1 and 2, find a way to write the estimated number of stars in the universe as a power of 10. Well, we found out that there were 100 billion times 100 billion, and that means it's 100 followed by 9 zeros times 100 followed by 9 zeros, and that means we have to multiply 10 22 times. So we have 10 times 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 10, and we do this 22 times. But this is the same thing as 10 to the 22nd power. In example number 4, we find that there are approximately 317 million Americans, and the average American has $3,800 in their savings. We want to use our calculator to calculate the approximate total amount of money saved by Americans. And we want to write down what appears on our calculator screen. So let's plug in the numbers into our calculator and see what turns up. So I plug in the numbers for 317 million Americans times $3,800 per American. And then my calculator gives me this big, long number with no commas, and it's really difficult to read. Some calculators, the example is too large to even show up on the screen. And in this case, the number may be given in scientific notation. When dealing with very large or very small numbers, it is inconvenient to write them in standard form. Scientists agreed on a mathematical convention that represented numbers in scientific notation. Scientific notation is used to express very large numbers in a shorter form by writing them in powers of 10. It could also be used for very, very small numbers too. Calculators are already programmed to give output in scientific notation when the calculator's results in a number that is very large. For example, the number 1204600000000 may not fit on the screen of most standard calculators. Depending on your calculator, you may see one of the following in the calculator window. 1.2046 E12, 1.2046 big E12, 1.2046 underscore 12, or 1.2046 space 12, all which mean 1.2046 times 10 to the 12th power. In the standard notation, this is what we saw in the previous calculator on the previous slide. A number written in scientific notation takes the form a times 10 to the b power. Remember, the exponent represents a repeated multiplication, and therefore it is done before the multiplication by a. Also remember that every time a number is multiplied by each power of 10, a decimal point moves one place to the right. For example, 8.5 times 10 to the 8th, where a is 8.5, this number is written in scientific notation because 8.5 is greater than or equal to 1, and 8.5 is less than 10, and b is equal to 8 is the exponent power of 10. To rewrite the number in the expanded form, we use order of operations. Step 1, exponent 10 to the 8th power is equal to 1 with 8 zeros after it, or 100 million. In step 2, we multiply 8.5 times 100 million, which is equal to 850 million. The decimal point moved 8 places to the right, or 8 orders of magnitude. In question number 5, we're going to decide whether the number below is written in scientific notation or not. For the ones that are not, we're going to change them into scientific notation. So here we have 4.03 times 10 to the 3rd, and yes, this is scientific notation. In B, we have 250 million. This is not scientific notation. So we want to rewrite this as scientific notation, so we have to go in 1, 2, 3, 4, 5, 6, 7, 8. So that means it's 2.5 times 10 to the 8th. And for C, this is not written in scientific notation because 21 is greater than 10. And in scientific notation, we have to move this over one space to the right, and that means we're going to add 1 to the 5, so we get 2.1 times 10 to the 6th. Example number 6. In 2013, the total population of Asia was approximately 4.3 billion people. How would we write this in standard and scientific notation? We can write this as 4,300,000 people in standard notation, or 4.3 times 10 to the 9th people in scientific notation. Thank you very much. I hope that you enjoyed this video. Be well, take care, and goodbye for now.